So C is the speed of light in vacuum or air, and V is the speed of light in any given medium, and N is represents the refractive index. We know the value of C is 3 into 10 to the power 8 meter per second. Now when the light enters any medium, its speed will become different from this. So it can become, generally it becomes smaller than the speed of light in air or vacuum. Okay, so as the light moves from air or vacuum into the medium, the speed will decrease. And always C is greater than V. And therefore the value of N is always greater than 1. Okay. And refractive index, because this is speed of light, this is also speed of light. So units are equal, same. So N has no units. So it is unitless. Okay, now refractive index, relative refractive index. That is the second type. So if we have suppose two media, so this is the interface of two media XY, and the medium on top is say medium 1, and this is medium 2. Okay, well, we can take an example of air, and this is suppose glass is a medium 2. Now when a ray of light is incident at the interface obliquely, suppose along AO, then it will always bend towards the normal. So it is incident along AO, it will refract along OB, such that the angle I of incidence is larger than the angle R of refraction. So this is the normal drawn at the point of incidence. Okay. Now, speed of light in air is suppose V1, and speed of light in the medium 2, that is glass, is V2. Okay, then the refractive index, relative refractive index, is defined as, so we can say relative refractive index of second medium with respect to 1. That is refractive index of second medium with respect to 1 will be given by the speed of light in the first medium divided by speed of light in the second medium. So that is how we find out the relative refractive index. Now this is relative, means it is the refractive index in relation to of second medium in relation to first. So n to 1 means refractive index of second medium with respect to refractive index of first medium. Okay, or you can say refractive index of, or this is the absolute refractive index of second medium with respect to absolute refractive index of first medium. So we can write down like this also, n21 is equal to n2 divided by n1. Now n2 we find out using this relation. So refractive index of second medium will be equal to n2, that is absolute refractive index of second medium is speed of light in vacuum or air divided by speed of light in glass or second medium, so V2. And n1 will be equal to c, that is refract speed of light in vacuum or air divided by speed of light in the first medium, that is V1. So that is, these are the two absolute refractive indices, n1 and n2, and refractive index of second medium with respect to 1 is equal to n2 divided by n1, where n2 is c divided by v2, n1 is c divided by v1. Now if we put these values of n2 and n1 in this, what we'll get is automatically c upon v2 divided by c upon v1. So I'll write down here. So n21, which is n2 is c divided by v2, n1 is c divided by v1. It will become v1 divided by v2. So refractive index of second medium with respect to 1 is the speed of light in first medium divided by speed of light in second medium. Similarly, we can also write down n12. So if you want to find out the refractive index of first medium with respect to second medium, so it will be refractive index of first medium divided by refractive index of second medium. Now put these values, c upon v1 divided by c upon v2. What you get is v2 divided by v1. So refractive index of second medium with respect to the first medium is equal to speed of light in the second medium divided by speed of light in the first medium. So whenever you are trying to find out the relative refractive index, that is refractive index of one medium with respect to the refractive index of the second medium, then it is the ratio of speed of light in the first medium to the speed of light in the second medium. So that is how you find out the relative refractive index. And absolute refractive index is also kind of relative refractive index, but now in this case the first medium is always vacuum or air, where the speed of light is always c. So this is the refractive index of any medium with respect to refractive index of air or vacuum. Here the first medium is always air or vacuum. Here the first medium can be any medium. It can be water, it can be glass, it can be air, it can be vacuum, it can be any other medium. So that is a relative refractive index. Again, the units, there are no units for refractive index, neither absolute nor relative. So 7 colors which consist of light, which light consists are Vibgyor, represented by violet, indigo, blue, green, yellow, orange, and red. Now speed of all these colors is different in any medium. Suppose VI, VB, VG, VY, VO, and VR all are the speeds of different colors, and these are different. So all these will travel in glass medium with different speeds. So when we have a prism here, and when the white light enters the prism, as soon as it enters, all the colors will start moving with different speeds. So what is the effect of the different speed? air. Suppose this is going from air and this medium is glass. Okay, then refractive index. Let us find out the refractive index of glass. So N of glass with respect to air. So NGA means refractive index of glass with respect to air. So will be given by speed of light in air, that is C, divided by speed of light in glass. So speed of light in glass. Now the speed of light in glass of different colors is different. Okay, in the speed of light in glass of violet color is suppose VV, of indigo is VI, VB, V and V red. So speed for red color, the refractive index for red color will now be equal to C upon VR for red color. Now for violet color, it will be C upon VV. Now because these two are different, so values of refractive index for red color is different and for violet color is different. So the same medium glass has different value of refractive index for red color and violet color and all the other colors. So that is why all the different colors are refracted through different angles, because the speed of light is different and all these colors are refracted through different angles and therefore they all separate. Okay, so all of these colors will separate, and that is why we are able to see all the different 7 colors separately. So this is how the colors will separate. So this is suppose red color and this is violet color. Okay, and all the intermediate colors are in between. Okay, because the speed of light all the intermediate colors is different. Okay, so refractive index of any medium for different colors of light is different, and therefore we know refractive index is sin I upon sin R, that is using the Snell's law. So according to Snell's law, refractive index is sin I upon sin R. Now because refractive index for red color is different and refractive index of violet color is different, sin R is different. So therefore, because for the same angle of incidence, the value of angle of refraction will be different, because this value is different. So refraction, angle of refraction, because angle of incidence is same for all the colors, but the angle of refraction will change because the refractive index has changed. Why it has changed? Because the speed of light of these colors is different. Because of the change in speed of light, because of the difference in speed of light of different colors, the refractive indices are different, and therefore the angle of refraction is also different, and that is why they are refracted through different angles, and that is why they separate, and that is the cause of dispersion of light. Now why the these colors have different speeds? Because they have different wavelengths. So wavelength of red color is maximum and wavelength of violet color is minimum, because the wave color of the light, white light, colors in the white light have different wavelengths, and that is why they have different colors. Now, how the wavelength is related with? Because the light is energy, it has wavelength, it is a wave, and it has frequency also. So frequency represented by nu. So it is v kind of letter nu, and relation between speed and frequency and wavelength is v is equal to nu lambda. So just remember this: v, the speed of any wave, is equal to frequency multiplied by wavelength. So light is also a wave. So speed of red color will be equal to frequency of red color multiplied by wavelength of red color in any medium. But remember, the frequency never changes. So with light, when it goes from one medium to another, there is no change in frequency. So frequency of light remains same. So if wavelength changes, speed will change. So that is why speed of light changes. Speed of light of different colors changes because their wavelengths are different. Therefore, the speeds are different. So once again, to summarize, the different colors of white light, which are constituent colors, 7 colors, have different wavelengths. Wavelength of red color is maximum, wavelength of violet color is minimum. And in different media, because of the difference in wavelength, their speeds are different. They all move with different speeds. Because their speeds are different, the refractive index of any medium for different color is different. For different color of light, the refractive index of glass is different, because refractive index is the ratio of speed of light in air to the speed of light in medium of that color. Now red color has different speed and violet color has different speed. So this has maximum speed. So the refractive index of glass for red color will be minimum, and it has minimum speed. Refractive index of glass for violet color will be maximum. Now because refractive indices are different for different colors, they are refracted through different angles, because refractive index is sine I divided by sine R. For, for red color, it will be equal to sine I divided by sine R. Because NR is different and NV is different, these angles will be different, but I remains same because I is same for all the colors. So refraction, angle of refraction will be different for different colors, and that is why they all separate. That is why they are all refracted through different angles. So this is the angle of refraction for violet color, and this is the angle of refraction for red color. So for red color, angle of refraction is maximum, and for violet color it is minimum. For red color, angle of refraction is minimum, and for violet color it will be maximum. The angle of deviation, it is the angle through which the original path of the incident light changes when it enters from one medium to the other medium, represented by delta. So if I is the angle of incidence, that is between the normal and the incident ray, and it is suppose going from one medium to the other, it is bending from its path. Now the angle with the normal of this ray along OB is R, that is angle of refraction. But if this medium was not present, it would have gone straight, that is original path along AOC. But it has deviated from this path and it is moving from O2 along OB. So about this is the angle through which it has deviated from its original path. That is called the angle of deviation, and the value of this angle will be angle I minus angle R. So that is the difference between angle of incidence and angle of diffraction. Now here also different colors are refracted through different angles. So therefore the angle of deviation for different color is also different. So this is the original path of light. Because of the prism, the path changes, and this is the final path for red color, and this is the final path for violet color. So when you extend this, the line along which violet color is diffracted, find out the angle between the original path of the incident light and the final path of the violet light. That angle is called the angle of deviation, represented by delta V. And the angle between the original path of incident light and the final emergent path of the red light will give you the angle of deviation for the red color. And the angle of deviation for red color is minimum, and angle of deviation for violet color is maximum.